Good day, I'm Mark Anthony Peña and I will discuss flood modeling. According to the European Union Floods Directive, flooding is defined as a covering by water of land that is usually not covered by water. If a dry land suddenly becomes covered by water, that indicates flooding. Flooding is not only caused by rainfall, and areas near the bodies of water such as rivers and lakes may also be flooded on a regular basis. Also, areas near the seashore may also be flooded due to tidal movements. Flood modeling is the simulation of behavior of water, mainly by using computer programs. Different data needs to be collected and prepared, and then afterwards, these data are used as variables for the simulation program. The output result is then analyzed and post-processed for information dissemination. Okay, firstly, what kind of data are needed? The basic kind of data needed are digital elevation model, which is the topographic data of the terrain, and the rainfall data, which is the amount of rain falling on the terrain. Digital elevation model, or DEM, is gathered by land surveyors, and precise ground measurement is taken using scientific instruments such as the theodolite. And on a larger scale, light detection and ranging, or LiDAR technology, is used. LiDAR is a remote sensing method that uses light to measure the surface of the Earth, and these LiDAR instruments are usually mounted on airplanes and helicopters for surface data gathering. So the beauty of LiDAR, in addition to faster data gathering, is that it can also measure the elevation of land underwater. This means that aside from the topographic data, which is the land surface data, we can also obtain the bathymetric data, which is the seafloor and riverbed elevations. Aside from the digital elevation model, or DEM, we also need to know the rainfall values. Data is sourced from government agencies like the DOST PAGASA, which is the Philippine Atmospheric Geophysical and Astronomical Services Administration. And rainfall is variable. Different land areas have different rainfall values. And frequency of rain, also known as the rainfall return period, is the recurrence interval that this amount of rain will fall on a certain area. So heavy rain such as the Typhoon Ondoy is characterized by the National Hydraulic Research Center to be 180-year RRP. The Pagasa Science Garden Station recorded around 454 millimeters of rain during Typhoon Ondoy. Rainfall return period does not mean that the typhoon with similar strength will happen after 180 years, but there is the likelihood that such typhoon may again happen within 180 years. So for flood modeling, rainfall data for 100-year and 200-year return periods are used to prepare for the worst. Now that we have the necessary data, we create the model and start the flood simulation. There are many kinds of flood modeling programs, but there's one that is open source. Jervis Flow Solver is a program for solving partial differential equations describing fluid flow, which is suited for modeling water behavior. Simulation time depends on the size of the area to be modeled and may take hours or even days to complete. And this program is capable of generating both numerical grid data and video for floodwater height and velocity. So after the simulation is completed, the output is then analyzed and post-processed. Researchers and policymakers will use this information for disaster mitigation, risk analysis, urban planning, and emergency response. Private companies such as construction firms and insurance companies may also benefit from flood modeling information. Individual homeowners may also use this information to ensure disaster preparedness. So to sum it up, flood modeling is a computation-intensive simulation of water behavior that involves processing of digital elevation models and rainfall data values to create a better understanding of how flood water moves. Flood is a natural disaster that may cause loss of lives, and destruction of properties, and being prepared will help us minimize its effect to the society. This is Mark Anthony Pena, and thank you for watching.